Hello, ladies and gentlemen, and welcome back. Root Beer here with question 23 on our 2016 Fermat paper. 7 coins of 3 different sizes are placed flat on a table, arranged as shown in the diagram. Each coin, except the center one, touches 3 other coins. So, for example, this one here, 1, 2, 3, and the center one should touch 1, 2, 3, 4, 5, 6 coins. The center coin touches all the other coins. Okay. If the coins labeled C3 have a radius of 3, and those labeled C2 have a radius of 2, then the radius of the coin labeled X, this one in here, is closest to. Then we have some decimal answers. So immediately this makes me think I should probably reach for my calculator, because I'm probably going to do some math. Of course, it's a math contest. We weren't about to do poetry. But I'm probably going to do some math, get an expression, and probably have to use my calculator to, it looks like, approximate it to 3 decimal places. Maybe we'll be able to do it without a calculator. We'll see. But I want that handy anytime they say closest to, approximately equal, rounded to the nearest. Those are the things you really want your calculator for. Okay? So, with circles that are tangent to each other, touching each other at various points, I immediately think radii, and this suspicion is confirmed when they start telling me radii. So let's draw this picture a little bit bigger so that we can sort of mark it as we would like to. And I will draw this circle a little smaller. So there's that one. There's the slightly bigger ones. I think there were 3 C3s, did I see? Yeah, 3 C3s. So 3 of these slightly bigger ones. Okay. And then 2 more of these smaller ones. And then right in there was X. I'm going to color it in red. Actually, I don't feel like I have enough space there. Okay. Well, we'll put its radius in red. So what I would do is for each circle, I'm going to connect the radii up to these tangent points, the points of contact. Because, and it doesn't look like it on my picture here, so we'll let the blue be 2. That way I don't have to keep checking which circles are which. But you'll get a sort of a straight line. What we'll get is a series of triangles. So let the blues be, or the greens be length 3. Okay. And so what we actually have is a system of triangles, all sort of connected into each other around this central point here. And so these 2 greens, this is a distance of 6. Here's a distance of 5. When you add them up, 2 and 3 is 5, so there's another 5. So I guess we could actually draw the triangle. So 5, and then over by 6 to another 5. It doesn't have to be super exact. Another 5, another 6. And then 5s across here. And these become 4s. 2 blues make a 4. And then to the center over here of the X. And so that would be, let's call the little radius R. They didn't give it a name, did they? They just said the radius, right? Yeah, the radius of the coin labeled X. Let's just call it little r. Little x would be fine as well. So each of these distances is r plus the blue length, which is 2. R plus 2 and r plus 2 here. So we get a number of circles, and the first thing that strikes me as interesting is there's a symmetry. This should actually be a straight line cutting across, and we can see that on the original picture too. Cut across here, and it's the same image on the top as it is on the bottom. So there's nice little symmetry along this line. So that makes up a full 180 degrees. Now the only thing I don't know is this R here. But other than that, look at these triangles. They're all isosceles, which is kind of nifty. And we know around this center should be 360 degrees, so around this half, this line, should be 180 degrees. And if I know all three sides of these triangles, I should be able to get these interior angles, and then I can figure out this interior angle, and from there we might be able to use some trig identities. Yeah, because we can figure out this because it's isosceles, and then we could figure out this angle and probably use the cosine law. So we got a strategy here. So I'm going to zoom in here. R plus 2, R plus 2, 4, 5, 5, 5, and 6, I think. Yes. So let's figure out this angle here. So let's give it a name. Call it, say, theta. Actually, no, I can leave it as dot. That's fine. So cosine of dot is equal to, now I have to remember the cosine law. So 5 squared plus 5 squared, just in case you need a refresher. I mean, I don't use trig all the time in my job, so sometimes you forget these things. So if we've got an angle C here, cosine of C is equal to a squared plus b squared minus c squared over 2ab. Another way to write this is c squared is a squared plus b squared, which would be the normal Pythagorean relationship, except you have to do 2ab cos the angle C. But when C is 90 degrees, this goes away, and that's where you get the Pythagorean relationship, or the Pythagorean theorem. Anyway, so the two side ones are 5, so 5 squared plus 5 squared minus 6 squared over 2 times 5 times 5. So that, so cosine of dot will be 50 minus 36, so that would be 14 over 50, 7 out of 25. Okay. So 7 out of 25 there. And then we can figure out what check is. Cosine of check should be 4 squared plus 5 squared minus 5 squared, because this 5 here is the one that's opposite, divided by 2 times 4 times 5. So we'll get the 2 5 squareds will cancel out. We'll get 16 on top, divided by 2 times 4 times 5. So that should be 2/5. So the cosine of this is 7/25. The cosine of this is 2/5. I can figure out this remaining angle that I will call theta. So theta is 180 degrees minus dot minus check. So I'm just going to grab my calculator and do the cos inverse function. So 7/25 and 2/5. And I got to make sure that my calculator is set up for decimals rather than, or degrees rather than radians, which it is. So minusing the inverse cos of 7/25 will be 106.26. And then subtract cos inverse of 2/5. We should get 39.83838319. Okay. So that's good. I may have to come back to these if I need a slightly more accurate result, but okay, there's theta. Now, because it's isosceles, this is also theta, so this angle in here is 180 degrees minus 2 times theta. So let's call that phi. So phi is 180 degrees minus 2 theta. I've still got it on my calculator, so I'm going to multiply it by 2. So that's 79.6767667. And if I subtract 180 from that, I get 100.676. 0.3232336. I'm keeping as many decimals here as I can just because I know I'm going to have to be rounding to 3 decimal places at the end. And if I round early, a lot of little rounding errors can compound and might cause me to think the answer is one thing rather than not. That's why I'm listing out all these decimals, every decimal I see on here. Okay. So now that we've got phi, we can use another cosine relationship to figure out. All right, so the opposite, 4 squared, and that's going to be r plus 2 squared plus r plus 2 squared, minus 2, and there are r plus 2's on both sides, minus 2r plus 2 squared times cos phi. So 16 is 2r plus 2 squared minus 2r plus 2 squared cos phi. So divide by 2 on both sides. 8 is r plus 2 squared, and then we can factor that out, and so 1 minus cos phi. So I've still got the 100 and everything plugged in on my calculator. I'm going to just press cosine and then subtract that from 1 to keep all the decimals there. If I'd already done something, I can copy down the decimals that I've written down because I've been keeping careful eye and bookkeeping everything. All right, so cosine is negative 0.172 or 1792 and so on. So we'll do 1 minus that. So we'll have r plus 2 squared times 1.179201169. And then divide 8 by that. And we get 6.78425.379 should be my r plus 2 squared. So I square root it. R plus 2 should be 2.6046601, sorry, 014. Subtract 2 on both sides. R should be about 0.604660014. Because I've been keeping as many decimal places as I've been keeping as many decimals around as I could, I'm confident that when I now round this up to 605, that we should be good. And 605 is an answer of D. So that is exactly what I'm going to bubble in. And that should finish off question number 23 quite nicely. So we've got 2 more questions to go. Question 24 in the next video, and then 25 after that. If you haven't given them a try, I would strongly encourage you to do so. But other than that, enjoy your day, and I'll see you for more math next time.